We've built a Tomcat service, scaled it, and even put it behind a load balancer. But what happens when one of these replicas has a problem? A bug in an application takes it down, or an issue with the runtime hangs it? How do we detect that? Kubernetes defines a variety of ways of doing this. They're called health checks, or probes. They are what they sound like, a way of telling Kubernetes how to check the health of a given pod. Kubernetes has two types of health checks to ascertain two different things. First, Kubernetes uses readiness probes. Readiness probes are, well, what they sound like. Kubernetes uses them to determine when a pod is ready. After it has started the container, it can use a readiness check to see and ensure that that container is ready for work. Liveness probes determine when a pod is healthy or unhealthy after it has become ready. Whether it's a readiness probe or a liveness probe, you can use a variety of methods to ascertain a container's status. You can create a probe, whether it's for liveness or readiness, that uses HTTP or TCP to send a request to the pod. If it succeeds, it's deemed healthy. If it fails, in the connection or an HTTP error code is sent, it's deemed as a failure. Or you can specify a command to run on the pod inside the container. If that command exits normally with a 0 exit code, it's deemed a success. Anything else is deemed a failure. These probes, whatever they are, whether they're HTTP, TCP, or execution of a command, are defined on the container in a deployment or a pod specification. Let's go back to our Tomcat deployment to define a readiness probe and a liveness probe. The first thing we'll do in our example is that we will use a readiness probe to check whether the pod has started and is ready to begin taking requests. Most basically, we're just checking to see if Tomcat has started up, since this might take a while on some machines. Finally, once the readiness probe has indicated that the container is now ready to do work and accept work, the liveness probe will begin on the Tomcat deployment. That will begin to check at a given interval if Tomcat is accepting requests or if it's hung. From the GitHub repository, let's look at the basic and core concepts /health checks directory. The deployment.yaml file located inside it is what we're looking at now. You can find this file, again, under basic and core concepts /health checks in the GitHub repository. Take a moment to open it if you need. You'll notice it looks pretty familiar. The file, up until about a little bit more than halfway down, looks exactly the same. We've added two stanzas, the liveness probe and the readiness probe. You'll notice that these two stanzas have a lot in common in themselves. In fact, the way you define a liveness probe and a readiness probe, the actual format, is exactly the same. You'll notice a few differences in a few of the properties within each one. That's because we need them to do different things. Remember, the readiness probe at the bottom of the file is our way of telling Kubernetes how to test to make sure that when it starts the pod, that it is ready for work. In this case, we'll tell it to access port 8080 every 3 seconds after an initial delay of 15 seconds on simply the / directory. Once this succeeds, Kubernetes will know that the pod is ready for business. After that, it'll go to the liveness probe. Every 30 seconds, after an initial delay of 30 seconds, it will use HTTP to access port 8080 on the / path. If the HTTP request fails, it will deem the pod to be unhealthy. We'll go over what happens later. If the HTTP request succeeds, it's deemed to be healthy. Let's begin by checking to make sure we have the right deployments file. From the health checks directory, let's look at the deployment.yaml file. A liveness probe and a readiness probe. Looks good. Let's use the kubectl apply-f command and pointing to our deployment.yaml file to apply the contents of it to our cluster. Once it's applied, let's use the kubectl describe command. by specifying deployment, tomcat-deployment, to look at the details. You'll see this output looks pretty similar, except now we see a liveness and a readiness line.